Good morning, everyone. Good morning. How is everyone doing? Good. Wonderful. Well, so I am Dr. Liraz, and today I want to help you see the field in a different light. So I'm a child development expert, and the world I come from is the world of science. So I will sprinkle in science as we proceed this morning, but I want you to know that we have an action-packed morning. I have an hour and a half for you where we're going to not only learn about certain concepts of child brain development, but also we're going to experience some of them, and I think that's very, very powerful. Okay, so as we begin today, I want you to think about the fact that at every age and every stage, there is something that we can do for our children to maximize brain developmental potential. And that's exactly what my goal is, to empower you, to help you see things in a different light. And so if you think about it, there's always something we can do to alter the trajectory of the brain. Even if we're talking about a child with ADHD or a child with autism, we could always try to find a way to alter and chisel the neural pathways, especially if we intervene early. And today's talk is geared towards children ages 0 to 8 because we know that that age range is where the most development happens. Meaning of course, you hear all kinds of things in the field. The first 3 years of life are the most important. The 5 years of life, the beginning of the childhood are very important. But I'm here to tell you that the first 8 years is where the magic happens. Because the first 8 years hold in the brain the most times. It's the time where the sensitive periods occur. So what that means is there are particular windows of opportunity in the human brain where if you want to master a certain skill, like a native, whether it's language or music, that's when it happens, those first 8 years. So there's a huge potential to affect change, and I hope today that we could all see that. So I begin with a little story. A friend of mine is a percussionist in a salsa band. This is not your average band. It's actually a high-energy, upbeat salsa band. Now, his job is very important as being the percussionist of a Latin kind of band, where the stage has many different musicians. You don't only have 10 to 12 musicians, you might also have the singers coming along and singing to beautiful melodies. But back to my friend's job, basically, he is responsible to keep a steady beat. As the band is playing, they're following his lead. He is the heartbeat. He is the metronome. He's the livelihood of this band where all other players, musicians, and singers must synchronize together to make these gorgeous salsa melodies. Now, if you've never ever experienced a night where you go out and you listen to live music like this, then I suggest you do. Because when you see something like this, you don't only hear the music and see the musicians, you can also feel it. And believe it or not, it's a multi-sensory experience where we get to immerse not only through our auditory cortex as the music is coming into our ears, our visual cortex as we are taking in all the visual information of the musicians dancing and moving around on stage and playing their instruments, but also it could be a tactile experience where your feet start automatically moving and now you must grab the friend you have right there, take them by the hand, and now you feel the warmth of their skin and you're dancing. Before you know it, you're dancing. And so because it's a night like this could be a lot of fun and people dress up, you might also smell everybody smelling good with their perfumes, and you must also bring along some snacks to taste as the night goes. Now, here's the bottom line. What does a salsa band have anything to do with child development? And I'm here to tell you everything. Because as the child's brain develops, we know that there's a concept called neuroplasticity, which we will get into. But this is essentially, it chisels the brain's learning pathways. It is essentially how we adopt and how we grow and how the brain becomes dynamic. And that's one of our advantages as human species. We could adapt and grow and shape according to our environment and the world. And so something like this that is multisensory, even for us adults, is not only therapeutic and builds community and puts us in a good mood, but it also helps us learn better. Because when the brain receives sensory information from all the senses, I just named 5 different senses, then we know it chisels the neuronal pathways, the experience is more robust, and the learning is magnified. When we look out into nature, we see beauty all around us in nature. And what's fascinating about nature is that nature proceeds according to its own timing, right? But nature is very efficient at getting everything done. And that is exactly my point here with the cheetah. Will a cheetah that is so magnificent and such a powerful and agile animal, will it not want to run as fast as it possibly can? Just by design. What about a tree? If we give a tree the proper sunlight, nutrients, and water, will a tree not want to grow to be the tallest tree possible and the greenest tree and the most robust tree in the area? Taking those same concepts, we can translate into child development. So when a child's brain develops, by default, it wants to reach its full optimized potential. Yet, there's a big gap that exists between what we do with our kids and for our kids and what actually we know that works in the sciences and in the literature and in all the parenting books. So my goal is to bridge that gap for you today. What's very interesting, experts in the field will tell you, that the first 60 days of a child's life are the key. And that's really fascinating because you hear all kinds of things. But what happens in those first 2 months of life that you may not be aware of is that the groundwork for those brain pathways, everything that the more complicated skills we build upon, whether we're talking about social emotional intelligence, you're talking about cognitive development, we're talking about executive function and motor skills, everything has to do with what happens in the first 60 days of life. That's pretty mind-boggling concept. That means that the way the children start their life is everything. And I always like to say, it's kind of my phrase, let's get it right from the start, right? We want to set our children up for success. And the way we can do that is, all development is important, but the key is really the first 60 days of life. And you can think of it sort of like a house where we establish those pathways. Keep in mind, the brain is still not wired. It's very, very immature. But what's happening is those pathways, from the moment the baby sees the caregiver's smiling faces, everything starts building from the ground up. And so it's very important to keep this in mind. You're watching now the brain in real time. What you're seeing is neurons firing at a rapid rate, and the neurons are the functional structural units of the brain. Now, along with those neurons, you see connections. Those are called axons. And the axons are responsible, they're like telephone wires. They're responsible to connecting one neuron to its neighboring friend. And that is how the brain is able to be efficient, intelligent, and operate quickly. Now, as the baby is born, we know that the brain contains 100 billion neurons. Think about that number. That is as big of a number as the number of stars in our Milky Way galaxy. But the neurons are still not connected. And over development, the brain starts making those connections according to the child's environmental needs. So what does the child need? Does he need to learn the English language? Does he need to know how to play the piano? Does he need to know how to interact with a family dog so he doesn't get bitten? All those things come into effect when development happens from the ground up. What we also know is that each one of these nerve cells, and I'm going to play it again because it's just such a lovely video, whoops, but each one of those nerve cells basically makes between 10 to 15,000 connections. That means that the possibilities of wiring each and every one of our brains and each and every child's brain is different, so the magnitude is great. We can get all kinds of people, and you mix it with temperaments, and that's why we are so different as individuals. It's what happens in the first period of life, and of course later on, as the brain experiences the world. Now, I like to think about the brain in terms of a brain mosaic. I think it's a very powerful concept and useful in this way. So if you think about the brain is composed of many different structures, and each structure has a function. But individually, the structures are meaningless. It's only when they come together that we get the complicated skills that we can perform as humans. We're the ones that can invent French fries, and we have technology nowadays, and we could fly a man to the moon, and we could do all these things, but it all begins by integration, when we can connect the left hemisphere with the right hemisphere, connected, and the more connections we have, the better the brain is functionally. And so a mosaic is a kind of an older concept, artistic concept. Back in the 3rd century AD in ancient Rome, they used to decorate house floors, they would even have them along the walls in these beautiful mosaics. Now, what is a mosaic? It's simply taking tiles of different colors and putting them in a certain pattern, and artists would normally do that, to create gorgeous pictures like this. And this lady is called the Mona Lisa of the Galilee being an ancient or a region actually in the north part of modern day Israel, the country of Israel. And so in one of these Roman official houses, obviously he was well-to-do because not everybody could afford a mosaic in their home. And so in the house, he had the mosaic there. Now, this woman is Mona Lisa. She's called Mona Lisa because everywhere you go, everywhere you look, whether you're sitting on my left or you're sitting on my right, Mona Lisa is looking at you, and she has that smirk about her. So, in a day and age, in the 3rd century AD, in a day and age where we don't have technology, how are we going to entertain our guests? It was actually found in the dining room of this Roman official. We're going to have gorgeous pictures to look at. And it's kind of like putting up a poster of Kim Kardashian, right? And so that is a useful concept to think about, where we try to think about integration. Each one of those styles are meaningless, but when an artist puts it together, we have a beautiful mosaic. Okay, so what another really interesting thing about a mosaic is that the brain works in this way, in integrating the structure so that we can perform functions, like I said, very particular functions. But did you know, for example, this is a really powerful example from the human brain, even in you and me, because see, when I talk about the brain, I'm not just talking about kids. We're talking about our brains as well. This is where it really becomes personal. So we have in the middle of the brain, we have a structure called the amygdala, the center for human emotions, that is sitting right next door to the hippocampus. This is the middle of the brain. Okay. Because they're anatomically sitting next to one another in the brain, structure and function and anatomy, it all combines to give you projections between the two brain structures. So what that means, the hippocampus is responsible for learning and memory. The amygdala stores human emotions like stress and happiness and sadness. What happens when you combine the projections going back and forth from the amygdala to the hippocampus, you're getting emotional memory. So many of you could probably remember the day of your wedding. That was such an emotionally charged day, such a heightened state of emotion. And so when you think about that, how is that memory seared in your brain? It's because the emotions triggered connections between the hippocampus and the amygdala. And now not only can you remember your wedding day and who you married, you could also remember what you had for dinner that night. Something that, I don't know about you, but I cannot remember what I ate last night. Another thing, if you deliver a baby, those memories, the colors on the wall, the faces of the staff and the doctors, everything gets ingrained because biology, neurophysiology, and function goes hand in hand. So that's the beauty behind that. Going back to the fact that the brain works like a well-oiled, efficient machine is the fact that the brain is interconnected. What I mean by that is that the concepts apply of syncing everything, just like my friend does as a percussionist for the salsa band. He must sync everybody on the same beat of the same music. We want all the brain structures and function syncing. And the more syncing you can do and the more crosstalks, one neuron, another neuron communicates across different functions, across the two hemispheres, the better brain that you're building. And so here we have a pyramid. I kind of stacked some certain functions. I hope you could see it from the back over there. But basically, we have the groundwork being laid for our children. This is sort of the primary brain networks that if you want a child to achieve a maximal optimal level of proficiency at anything, being independent, being disciplined, going on to have a marvelous academic career, being a musician, being able to play on the soccer team, all of those skills require elementary brain functions. What am I referring to? Physical, mental, social, and emotional, those building blocks, those brain networks and circuits must be first. They must be established, as we talked about. They are beginning to get established during the beginning of life, the first 2 months. But then, during the first few years of life, mainly today we're talking about 0 to 8, these brain networks become more wired, more coherent, stronger. Their neurons are firing together, they're wiring together, they're connected. And now we can take a child and say, all right, what would you like to do? Would you like to enroll in an art class? Would you like to achieve something a little more complex? And yes, go ahead.
Sorry, really quick. I have a child who speaks 2 different languages.
Mm-hmm.
And like we do our circle time and read our books, but he wants nothing to do with it. And like his speech is delayed, but I know he's not. I mean, I just wonder, like, how does that work when he's trying to figure out us when his household speaks nothing but the other language?
So he's bilingual, which is a plus. That's actually not a factor we'll talk about today, but bilingualism is great.
Yeah, he's only 3 right now, and I mean, his speech is limited as it is, but I mean, I know he understands what we're saying. I guess I'm just trying to figure out how that all works with him and his brain.
Okay. So of course, not all brains are wired differently. That's a good question. That sounds like an unusual situation, right? We would expect a child, normal development occurs according to what I'm speaking of. But then we have another another topic, which is called neurodivergence. What happens, it's not abnormal, it's just different. What happens when the brain develops autism, right, and different conditions, ADHD, but what happens, the wiring is not the same. The brain structures may not develop optimally like I'm referring to today. So in that case, I'm not sure, each child, and I'm not a clinician working with the kids in the clinic, but in that way, but so each child, it's individual and it's hard to tell. But thank you for your question. Yeah, we have to dig in deeper, and of course, we shouldn't be the experts in that. We should refer the children out to the experts. But the point I'm trying to make is that once you get a strong foundation in place, as you see in this diagram, then you could say, all right, now we have an independent child that is capable of doing so much, and now we can build. If he wants to learn calculus, fine, we're going to teach him calculus. We're going to teach him astrophysics. All these difficulties, the difficult subjects are building upon, right, the simpler ones. And that's how the brain constructs itself. And in fact, did you know that as humans, we have a very long development as compared to other animals in the animal kingdom, because our brains are just way more complex. They require more time to develop. And I have independence on the top that reminds me, our children don't leave the home until they're what, 18? That is a long time to stay with mom and dad, right? But to achieve that level of proficiency as human beings, to do what we do, we're managing so much, we're doing so much, we must allow the brain all this time to develop. And in fact, I'll also tell you that something fascinating. We know that the human brain for children, it does not stop developing until mid to late 20s. Simply what that means is that you think you're done developing at 8. You think oh wow, the child is so independent now. He's 14, he's taking the bike and he's going and he can go to Starbucks on his own. Great, but but the brain still hasn't developed fully. That's why our teenagers, we don't understand when they make poor decisions. We don't understand why college kids act that way. It's because the brain is not, it's not just develop and you're done. It's a dynamic process that lasts to the mid to late 20s. So that's something really interesting. And speaking of development and time, I love this. This is an illustration of the human brain. Now, this is, keep in mind, we're talking about millions of years of human evolution to get us to the point we are today. So you don't have to be an expert, you don't have to be an anthropologist, in fact, to appreciate the fact that over time, over millions of years, the human skull has been increasing in size. Not only that, the human brain has been growing, making connections, more connections, and increasing in the number of neurons, meaning the nerve cells. That is over time. And just as we split off, you know, evolution is complex, but just as we split off our chimpanzee ancestors, we experienced a massive boom in development. So I'll show you what that means. So basically, the human brain had something we call an intellectual explosion. All of a sudden, people discovered fire, and then it was a different ballgame. What I mean by that is fire, the invention of fire allowed human beings to go and hunt animals, to bring it back, to take the meat and to consume it, giving us more calories, more energy in the fat and the proteins, and allowing the brain to develop to even a bigger capacity. A larger brain, smarter brain, a brain that is well connected with all the different brain structures. Then humans said, okay, well, now that we're at this point, so the intellectual explosion continued, and now you get cave art. You get music when we sit in circle in a circle and we have tribal music. Humans figured out we could take a bone of an animal and make it into a flute. We could put some holes in it, and now it becomes a musical instrument. They also figured out with music development came language development. They said, well, now that we're living in tribes and we must cooperate to hunt these big game animals, and we have to find shelter and fight against the harsh environments. We can do all that. What we need a language. We need a way to really tell each other what we're thinking, how we're feeling. And that's how language and music and everything happened in parallel. And that is the beauty behind human development. Now, as I mentioned, neuroplasticity is a very important concept. That just simply means the ability of our brains to adapt to our environment. Neuro means neurons, plasticity means malleability, ability to change. Why that's important is because for any skills, I like to use the example of music, but you could substitute taekwondo, you could substitute hockey. Any kind of skill a child needs to learn is going to rely on this concept of neuroplasticity, on the ability of the brain to wire itself. And so this is a key concept that we'll keep referring to. Something else that's really key is that we know, experts tell us, that the human brain itself develops in reverse. So you see in this diagram, we're beginning with the back of the brain, then the middle of the brain, and finally the outer shell of the brain develops. Call it a shell, it's actually the cortex. So, believe it or not, this could be a brain model. So I'm going to walk you through what it looks like to have for the brain to develop and what all the brain structures are doing, and why it's going to be key for you today. It's not about just understanding the science, that's for the scientists. It's in order for you to take this information, and as we go on today, I'm going to show you how to use this concept to deal with challenging behaviors, for example, which is, by the way, the number one question that I get when I talk to preschools. What do we do with this kid? What do we do with that kid? If we understand the building blocks, the way that the development is by nature, the process of development, we can take that and use it to our advantage. And so that's what I'm going to do for you today. All right, brains are built from the bottom up, or essentially in reverse. This is the brain model. We have the spinal cord connected to the brainstem. The brainstem being the most primitive, ancient part of the human brain. So primitive, in fact, that it is 500 million years old. Now, what's so special about this brainstem, it's this chunk right here, is the fact that It is our autoregulatory center. Basically, all the autonomic functions, which means it's subconsciously, the brain is regulating your heart rate, your blood pressure, your digestion, your breathing. And why it's important is because, well, this is called the survival center. We really don't need to think about those things. The primary goal of nature is to keep us alive, and the brain was built in this way to do just that. And so the brainstem keeps us alive, and also behaviors that are very typical that you see all the time with kids and grown-ups even. All of us exhibit these survival behaviors that are the fight or flight responses. And that is integrated into this center called the brainstem. It's not just fight or flight. That's the classy one. Everybody says we either stay and fight or we run away. It's not only that, it's also the fawn response, and it's also the freeze response, and also the play dead response. All those biologically wired automatic responses that the brain and body say, whoa, this is too much for me. We got to go operate from that survival mode. That's what we're going to enter into. And so that is housed in the brainstem. Really key evolutionary area. All right, then we take our thumb, we fold it over, and your thumb becomes now yeah, you could do it with me. Go ahead. The thumb is now in the center of the brain. This area is called the midbrain or the limbic system. It's housing, as I talked about, the hippocampus and the amygdala. So learning and memory, emotions, and it's a very primitive center also. It developed approximately 300 million years ago. And this area is very important because it is our emotions, basically emotional regulation. Some adults get dysregulated, right? It's all firing, or the neurons are working from that center here of the limbic system. And finally, we take our hand, our brain model, and we fold it over, and now you get the whole brain. In fact, if you look at your fist right now in real time, I will tell you that it corresponds to the size of, they say that it corresponds to the size of like one hemisphere of your brain. So it's kind of interesting to see that. But the cortex, what I added on right now from an evolutionary perspective, is your cortex. The cortex is very important. It encases the whole brain, as you could see. It was constructed approximately, the prefrontal cortex was approximately 20 million years ago, fairly new on the scene. But what's important about the cortex is that this is where the magic happens. The cortex's primary job is to take in all the information from the world, take in the smells and the sounds and the tastes and the movements, everything, and it's going to make associations and integrate it. It's going to integrate it with previous memories, previous patterns. What do you know? What have you seen before that is similar to what you're seeing or hearing or feeling right now? And so the cortex is super important. But even more important is this, the fingernails. Yeah, we could check our manicure. The fingernails are very important because that is the prefrontal cortex. Now, the prefrontal cortex is an area of the brain that, as I said, evolutionarily developed less. And as I talked about, it doesn't stop developing in children until mid to late 20s. But this I call the brain CEO. Just like a CEO at a Fortune 500 company, what do? Well, they must plan and inhibit they have to inhibit themselves for doing anything to run the company into the ground. And so they have to coordinate, and they have to integrate, and they have to manage people, right? Everything that they have to do, which is very complex and problem solve, has to do with functions of the executive function center, the prefrontal cortex. So that's how the brains are built from the bottom up. And it is important because we must understand that before we can understand children. So maybe this would address some of you. You are wondering, okay, this is normal development, but I can think of a child that is like this or like that. What do we do with that information? So I'm going to tell you a very sad story. This happened approximately in 1980 in Bucharest, Romania. The socialist government of Romania decided, you know what, we are going to abolish abortions and contraception. So what happens to that population? They start having kids. Now there are too many kids and there's nothing to do with them. So the government says, okay, the solution is let's build orphanages. So lots and lots of orphanages were built to house these poor kids who were born into the world and now they are unwanted. And so the only problem was that the orphanages became so packed with kids that you had one caregiver to maybe a row of 50 newborns. There were not enough staff to take care of such children. So what happens is children became deprived. Developmentally deprived, they were neglected. They were not abused, but they were neglected. They didn't receive enough enrichment from the environment because we know that the brain is shaped by external environmental influences. There was not much of that at the time. And they didn't receive the sensory, we call it sensory motor stimulation. So motor movements, as simple as just crawling on the floor even. They were just confined to beds because you couldn't possibly watch so many kids. And so a research team, there were many researchers studying these kids during their development and then later on as adults. Researchers teams came to study these children to say, what has happened in their development to cause this? How did their brain develop? They could image them. They could study their behavior. And it might not surprise you to know, like this little girl, it's a picture from the orphanages. This little girl is 8 years old, actually. Biologically, she's 8. Her brain is actually stuck in a 3-year-old mode. So it's like a 3-year-old that when they found her, she's standing in that field, sucking on a rattle, wetting her pants, and crying, sometimes frequently having temper tantrums, and nobody was around to take care of her. That's just one example of these children. So you might ask yourself, well, okay, we know what's gone wrong, but how is the brain manifesting? So what, if we could look inside her brain, what would we see? What behavioral changes has she exhibited? And the answer is a lot of different things. From executive function, so low IQ, she was found with low IQ. These children didn't, of course, that beautiful video I showed you of the neurons making pathways, those pathways were compromised, so gray and white matter, those were compromised. We also saw, as the researchers studied these children, they saw social emotional problems. Of course, that's not surprising because they didn't have a caregiver taking care of them. They never received that one-to-one, we call it back and forth interactions, the serve and return interactions. And so there were a lot of problems, and of course, emotional problems, couldn't connect to others, bonding. And so the question I have for you today is if you were one of those researchers on the team and you came there and you saw it, or if you were a therapist, or you had some training in this, and you were her pediatrician of this little girl, what would you do now? How would you deal with this girl? Given that you know that the brain has a miraculous ability of neuroplasticity, which means it could still change, it could still mold itself, it's still resilient, and given the proper experiences, you can intervene, what would you do? I just want you to think about it for one minute. Because this is where we're going back to that fact I shared with you, that the human brain is built from the bottom up. And this is where it becomes useful. There's a guy, a very famous doctor, Bruce Perry, who wrote a book. He co-authored a book with Oprah Winfrey, the Oprah. And so it's called What Happened to You. And Bruce Perry is a trauma expert. He's a well-known trauma expert. His focus is, what do we do with kids like this? So that's where he develops using this book. It's a phenomenal book if you want to read it. And we'll answer all your questions about what happens when development doesn't go accordingly and what do we do with trauma-affected children.
Isn't it kids who experience trauma from the get-go, that little thing? I mean, how numb are they to actual experiences versus kids that didn't grow up like that?
I see. Well, it depends. It depends if the trauma, let's say the parents, so it depends. If the situation is, so trauma is, it's a big umbrella term. We have abuse, neglect, sexual molestation. We have so much under that umbrella. It depends. Did you have a steady caregiver from the moment you were born? Were you shuttled around?
Because you said she was born in an orphanage, she was
Yes.
limited any contact.
Mm-hmm.
So what is that? And like all of her reflexes versus
Oh.
a kid that actually grew up different. You know what I mean?
Right. Well, I would say it's really individual. You can't generalize in this way. I reported to you what the research teams reported in their studies based on not just her, a bunch of kids that they studied, right? It's kind of, you're clumping everybody in a category and you're saying overall executive function, social emotional, motor skills, all these basic skills that I covered with you at the very beginning of that pyramid, those did not develop well. But there are success stories. So that book, if you want to read it, goes into vivid examples because Bruce Perry he has a lot of experience with children and trauma. So he goes into the fact that if you take a 2-month-old, it all depends when the trauma happened, when. So if you take a 2-month-old and they started life wonderfully, just like normal development, and all of a sudden a big disaster occurred, and now they lost their parents, and now they're being shuttled into orphanages. But wait, they received that chiseling of the neuronal pathways the right proper way at the first 2 months of life. Will those kids traced into adulthood, what will happen to them? That's the question. They can, given the proper, of course, they might need support. They'll need therapists. They'll need caregivers. They may need a foster family who takes them in. But if you take that child, whatever horribleness happened, let's say, after those 2 wonderful months, it doesn't matter. Because overdevelopment, you work with them and the brain is so resilient, you could fix it. Meaning you could create a normal functioning adult years down the road if the child is willing and able to work through all those difficulties. So that's what we're talking about. That is the beauty, and I love that. That means that no, hope is not lost. At any situation almost, you can reverse, you could turn things around. Maybe not 100%, but you can still do something. And that's where I want to take you today, into the neurodevelopmental model, because that's going to drive home the point of why did I explain how the brain developed and how can we use that information. I love information that you can actually take with you. All right, so this is it. This is what Bruce Perry says. He says, because we know in biology the brain is built from the bottom up in reverse, we're going to use that information in all of the all the trauma kids that I will now come across. I'm going to use it to regulate them. Because honestly, trauma-affected kids get dysregulated a lot. They could go right from 0 to 100 in no time, and they could have the tantrums, and we have to access them. Now, if we do what all of us, I know I'm guilty of this, I want to immediately talk to the child. But we know that talking to the child never ever works. Not in that heightened state, not if they come from a trauma background. So what do? That is where the bottom-up approach starts. First, we look at the back of the brain. We called it the brainstem. If we can get a hold of the brainstem, meaning if we can regulate that, then everything else will fall into place. We'll start there. So what he does with the trauma kids is he takes a kid and he says, all right, to regulate this center, the brainstem is our survival center. The kid is now operating, screaming, he's operating, the body just wants to survive. What do we do with that? So we are going to use movement because we know this primitive center is geared in sensory motor skills. So that is actually the function of that center, sensory motor. So we are going to take the child, we'll rock it, we will take it on a gentle walk, any kind of movement, maybe it's a baby, so we're laid on the floor, we might move its limbs a little bit. Anything that we can do to introduce, it's not just movement, rhythm. Anything rhythmical, think about it. When you go take your bike on a bike ride, or you go have a dance class, or you go for a walk. These activities, doesn't matter what your favorite sport is, this is rhythmical. This is calming to the nervous system. And that's where we're starting. We're starting with the spinal cord, which is your nervous system, and the brainstem. We're going to start regulating the child that way. Once we tap into that, and you're saying, wait, how can I remember that? What do we do when we see a newborn screaming? That's an instinct whether you're the mom or not. We pick them up, and what do we do once we pick it up? And he's screaming. What do we do? Yes, we rock, we tap. Isn't that rhythm? We suit it in that way. We might, what I did, like put my daughter in a stroller, take her on a walk. We do those things because we know that rhythm is regulating. We know that intuitively. Yet we forget when we are dealing with a challenging child. First, regulate the center. Once you're done with that, we're going to move to the midbrain. Remember, that is the middle of the brain. And now the child is still not fully regulated. Now they're emotional, right? So we regulate the nervous system, but now the emotions are heightened. They might be crying. They might be, pushing us away. What do we do with, how do we regulate a child's emotion? I bet you know this already if you worked with kids. You don't even have to use words. Here, words are not important and probably shouldn't be used. You just have to be present with the child. You might sit side by side and color quietly. You might sit with them on the floor. Let's say they're interested in trucks. You might play with trucks for just a little while. No words are required. Just the fact that the child knows, hey, am I safe? Am I loved? Yes, this grown-up is taking time. They're right there next to me. I like that. That's soothing for their nervous system and for their emotional state. It's going to bring them from this to this. And once we're there, now we can do the adult thing we love to do. We were going to rationalize. We're going to reason. We're going to say, oh, don't worry, this happened. We can troubleshoot. Let me help you. And now you could talk to the child. And why? Because now you have access. You didn't have access to the cortex, our rational thinking, CEO center. You didn't before all these other parts were regulated. Now you do. And so this is where the model comes into place and how we're able to take a child with challenging behavior and bring them down. And by the way, it's not just for children. Don't adults get dysregulated? Colleagues, bosses, your husband, yeah. Everybody can get regulated sometimes, and this works really well. So, something to think about. Okay, so now you know. Now you know some of these were the core key concepts, but now we're jumping into the trifecta model. So all my work with children and with preschools and hearing what educators have to say, I took everything that we read about and hear about and all the challenges, and I clumped it into a model. And I call it a trifecta model just because if I could give you today 3 factors, 3 tools that could take development from where your child is and elevate it, sort of brain optimization techniques, this is the best I know of. The elements are, and they start with M, so hopefully we can remember them all. Movement, music, and multisensory experiences. And as I said, I don't want you to just hear about that. I want you to experience that. So we're going to go through and see what you think about each. All right. So we begin with movement. This is so amazing to me. If you think about movement, now I'm not talking about just exercise. Exercise is a form of movement. Movement can be moving your limbs in space. It could be yoga. It could be anything that moves the body. And we know that the brain and the body are connected. But if you looked at the hunter-gatherer tribes, and we have some of them still in existence today all over the world. One of them particularly is called the Hadza, and they're in Africa. If you look at them and their lifestyle, that tribe, and this is kind of a window into what we used to be like a long time ago as human civilization, the Hadza walk up to 10 miles per day. There's no day that they're sitting by the campfire and doing nothing. Because if they don't walk and get the food or gather the berries or build shelters, they will not survive. Walking is ingrained in them. What I'm trying to say is our brain evolved with movement. If we don't move, it's not going to work the same way. And so movement is, first of all, one of the best tools I know of to help children optimize their brain. And now something more interesting. Of course, you know that if we exercise, we're going to build a great cardiovascular system, we're going to be healthier, but that's not what I'm going to tell you today. That's true. But what I'm after here is how does this help build a better brain? So think about it. When we move the body, blood, oxygen, nutrients, everything's starting to flow. We have small little blood vessels called capillaries in our brains. They're getting perfused, they're getting nutrients, they're getting fresh oxygen. Now the brain is starting to fire. In fact, we know for a fact that when that happens, there are a whole host of molecules released into the human brain. What do I mean? Some of them you know. Endorphins, feel-good hormones, mood-boosting hormones. We have serotonin, makes us feel really, really good. These are neurotransmitters that are automatically released when we move, especially when we exercise, if it's a little more intense. Then what you have is dopamine. Dopamine is the focus and attention and reward type of molecule, or I should say neurotransmitter. When it's released in the brain, you're on fire. You're ready. You have an undivided attention and you're ready to focus on whatever's coming next. So that is a huge plus. And finally, we have another really interesting factor released. You might not have heard of it. It's called BDNF. BDNF is short for brain-derived neurotrophic factor. And why I highlight it, you can think of it like miracle grow for your brain. When it's sprinkled on, during and of course following exercise, what happens is it takes those axons we talked about and it builds a better brain by wiring the brain. It basically connects the brain better. So it's going to form those pathways, those connections between neurons, and allow children to what? Learn. So if you're a teacher at a school and you have a kid who just went out to exercise early in the morning, let's say it was recess time, and they came in, now BDNF is active, they're feeling good, they're happy, so you get the ideal student. This is a way to prepare and prime the brain for all the learning that's yet to come. Yet, when we look at our school systems, do we use that? Yes, we have recess here and there, but did you know that other countries around the world structure their day so that 50 minutes you sit, you listen to the teacher, you do your work, then 10 minutes you go and you're as active as could possibly be, whether it's outdoors or indoors. Then you come back, another 50 minutes, now 10-minute break, not just a break to eat something, but a break to move the body. And so when you build it in the school day, into the school day, you get a better brain. And why do we get a better brain? Because if you do this day in and day out over time, studies show that the hippocampus, remember, that's the Center for Learning and Memory, that increases in size. Over time, what this is meaning, what it means is that over time, the brain structure for learning, for memorizing, for converting short-term to long-term memory, it's actually, in essence, what makes us human, to remember our experiences and to build upon information. That structure gets bigger. So those kids excel academically much better than the kids who don't move. And that's why it's so, so important. Okay, so now it's your turn. We're going to do a little exercise. For this you just, you don't need to do too much, right there where you are. I ask you to not cheat, meaning don't snap pictures of the screen, don't write anything down, nothing, just use your memory for this exercise. So I'm going to, in a minute, I will present to you and read out a list of words. There are 8 words and they're slightly complex. What I want you to do for that short while I'm reading them, try really hard to memorize each and every word. It's a sort of a memory activity here. So here we go. Ubiquitous, pragmatic, convoluted, cacophony, ineffable, voracious, ambivalent, tenacious. Okay, so these are your words. And this is the part where I get to tell you how we can use movement, as I just did. But there are countries around the world that are doing it day in and day out. They're having their kids, this is in Scandinavian countries, like we have Norway and Finland and Denmark. What they're doing is they're having the kids run a mile around the school perimeter each and every day before school even starts. This is grade school, and these kids are actually kids from those regions. They're running the mile. By the time they get into their classroom, the teachers are so happy. They're focused, they're attentive, they're feeling good. Why? Because the mood-boosting hormones have been released, and now they are ready to sit and learn and focus. So that is just a powerful example of what can happen when you use exercise appropriately and kind of schedule it throughout the day. And so that is something I wanted to share with you. And I think the United States can learn a lot, because when you look back, every year they release the world statistics for testing. You know, which country in the world excels in math? And they rank all the countries by order. And the United States is not in a bad spot. But who comes in at number 1 and 2? It's always the Scandinavian countries. Of course, their education system is built differently. The teachers are incentivized differently. But the point is that they're also implementing movement, and their schedules are different. So that's something that we can learn from, because their test scores are so amazing and so much ahead than the rest of the world. What were those words? I asked you to recall. You could do it as a group. You could start yelling them out, and we'll see how many. Wait, one at a time, so I can mark.
Chromatic. Tenacious.
Wait, what did you say?
Chromatic.
That was not a word. Tenacious was good, yeah, that's one.
Cacophony.
Yes. Okay, 3.
Ambivalent. Ambiguous.
Ambiguous was not there, but ambivalent was. So you're at 4, you're at half.
Say the other word. Unpredictable or no, ubiquitous. Ambiguous.
What? That is not a word. what was it? I mean, you're on the right track, but
Ubiquitous. Yes.
what was it?
Ubiquitous.
Yes, so you got 5. Okay, 5 out of 8. That's pretty respectable. Let's see what you missed. Okay. So this, it's fun, right? It's short-term memory. I just wanted to do this to begin with, to warm you up. Now comes the real deal. Okay. So yeah, that was a warm-up. Okay, so now, very shortly, I'm going to ask you to stand. And with each word, we're going to do 8 more words, new words, just as difficult, the same difficulty level. Only this time, with each word that I'm reading, I'm going to associate it with a movement that symbolizes its meaning. And then I will ask you to remember those words, okay? So everybody stand up, please. Okay, and I'm going to display them on the screen as well as I'm reading them out. Here we go. Full out movements. Obtrusive. Unwittingly. Serendipitous. Magnanimity. Dichotomous. Labyrinth. Watch. This way. Okay. Let's see. We have quintessential. Okay. Quintessential is like this. And metacognition. All right. Have a seat. Yes. Thank you for doing that. We're going to test that in a minute. We're going to test that. Okay. I hope you enjoyed that as much as I did creating the exercise. Okay. All right. So this is the last concept for the movement I will introduce to you. I think it's so great. This is how movement is built into us as human beings when we develop. What I mean by that is when you look at this little baby, you see that at first he's on tummy time, right? As babies, we place them on tummy time. Why? Because they're going to start exploring the environment. Movement, in this case, as toddlers and children develop, is going to fine-tune those brain networks we talked about. So that is the whole secret, really. What does movement do from the tummy crawling baby to the cross-lateral movement of crawling on the floor, as little kids do, to standing up and starting to cruise furniture, to being able to walk and run and skip and play a sport? What does that have to do? That is how the brain develops, right? But here's the magic. It fine-tunes at each one of those stages. The brain is going to fine-tune itself. What do I mean? So if the baby is just on the floor reaching for a toy in tummy time, they're grabbing the toy and they're sensing the environment, right? So we have a little bit of sensory motor movement. Then by the time the baby starts crawling, each stage represents what the brain is doing and how the neuronal architecture is being built. Because next, the baby and the toddler actually will start crawling. This is called cross-lateral movement. What they're doing is they're connecting the hemisphere. The left and the right brain connections will start manifesting. We know a lot of diseases where the left and right hemisphere are not well connected, like autism. And so now we have to use tools to build it back up. Cross-lateral movement, even this is cross-lateral movement, but that's what the kids are naturally doing. That's by design. Nature designed it this way. By the time they're cruising furniture, now they're able to maybe walk on over to a sibling's room, and now they're experiencing the environment differently. At each stage, they're seeing and feeling and sensing something different. If you think about it, taking a baby from the floor to being able to stand up, and now they can go across the street and play with a neighbor. At each stage, it's designing a better brain, a more efficient brain, a brain that can move, a brain that can sense. And that is the bottom line here. I think that is very powerful. Now, quick personal story. So, when my daughter was 7 months old, I enrolled her in this cute, it's adorable little gymnastics class for little itty-bitty babies. And so all the babies are, at that point, they're kind of crawling around from one little equipment to another. And we had a very good friend at the time, also 7 months old. And her parents, she had amazing parents, but the parents were go-getters. They were type A, so type A, in fact, that they decided, our baby, we're going to determine this, that our baby will be the first one out of this. We have like 20, 30 people in that room, 30 babies. Well, our baby is going to be the first one to walk. We're going to put our mind into it and do it. So not long after, so their baby was first crawling, and all of a sudden she's getting up and she's starting to walk, she's wobbling over and starting to walk to all the grown-ups sitting in a circle and starting to interact with us in a beautiful social way. And I'm thinking, how is this possible? This little girl is just 7 months old and no other kid is doing that. So I talked to the mom and she says, nope, we put our mind to it every single day. We picked up the baby, we let her stand like this. First she was propped on furniture and then she started walking. What the parents did is they rushed development, right? They urged, encouraged, pressed on so that their baby can beat everybody else to walking. But I didn't know it back then. But today, when you look and you read about those things, it's a big no-no. When you rush nature in that way, when you rush the appropriate mechanisms of the brain and you urge a child to perform a skill, do something when the brain and the body are not ready for it, you're going to get into trouble. And what I mean by that, I did not track the child long term, but we know this from studies of other children, children with certain learning disabilities, children that have problem decoding letters later on in grade school. That is because they skipped stages, maybe. Maybe the brain was not ready, not necessarily that the parents pushed them, but maybe the brain needs to go backwards in time. So in therapy, what the therapists are going to do for a child like that, if they indeed are having learning, reading difficulties, sometimes if they think it's a developmental issue, the therapist will get on the ground with the child, doesn't matter that the child is second, third grader, and they'll start crawling with them. Why? Because now we are building a pathway, we are connecting the two hemispheres by strengthening those connections, and maybe the child didn't have enough time to crawl at those early stages. And so that's just something to think about. We cannot rush development. What were those words? The new list, the active list. Does anybody remember? Wait, metacognition, labyrinth, yes. Yes.
Serendipity.
Yes. You got this.
Dichotomous.
Dichotomous. We are at 5 already. That was quick. You can do it. What is?
Is it magna-cognitive?
We have that. Yep. So we have metacognitive, labyrinth, quintessential, dichotomous, serendipitous. We need 3 more.
Something serpentine. Wasn't there one of those?
That was serendipitous.
Oh, okay.
The first one? Yes, yes, yes. This one. Okay.
Obstructive.
Almost. Yes. Okay, so you're already at 6, so now I'm happy and we can stop. So you beat, okay, so you beat your record. So you beat your record. What does this mean? Here, this is the full list. Yeah. What happened in your brain? Okay, so first list, okay, difficult words, you try to purely memorize it. Second list, you added a movement. Now what? Now you have information coming in from different senses. Your body is moving in space, right? You're getting better input into the brain, so your brain will remember better. So it drives home the point that movement is really important. Important in learning, important in general. Now, moving is learning. Maria Montessori, I love just everything about Montessori classrooms, the philosophy, and she got it right in her Montessori lessons. And she was a medical doctor, so she knew a lot about the brain and the body, but she incorporated movement into her lessons. How did she do it? If you look at the toddler age classroom, some of their activities is, one of them is taking cards that have vocabulary words. These toddlers may not know what mittens are. They may not know what a coat is. They may not know what boots are. And these images are on cards. They place them in one side of the classroom, and the toddlers are asked to go get the card. So little Evie, can you go get me the mitten card? So little Evie has to go across this big room to run and get the card. She's moving as she's learning these vocabulary words. Then it gets more complex. The parts of